Am I audible? Hello.
Yes, sir.
Okay. So, some facts about SN. 2F, oh sorry, 2 1 to n. F is a bijection, then Sn is a group under if. That is check. This this group is called the symmetric group of order n. Symmetric group on I should write this or symmetric group of order n. If F belongs to Sn, we write a notation. Then F is a mapping 1 2 F1. This is here. This is a notation, and I1 I1 IR subset of 1 to n, the cycle of uh, 1 to n, then I1 R note the permutation I1 goes to I2, that I write I1 goes to I2 goes to I3, IR goes to I1, and J goes to J if J belongs to 1 to n minus IR.
স্যার রেকর্ডিংটা অন করেছেন তো?
হ্যাঁ, I1 IR is called a cycle of length R. Note that cardinality Sn is n factorial. Okay. A cycle of length 2 is called transposition. So uh, definition: the permutations element of Sn is called permutation. Okay. Of Sn are element an element, I write element, and is called a permutation. The permutations sigma 1 are Sn are said to be disjoint if for each and for each k in means this 1 to n set, in means 1 to n set, in sigma I k not equals to k implies sigma j k equals to k for all I not equals to j. So one element should permute by only one sigma. Okay. Observation: every non-identity permutation in Sn is uniquely up to parity. Parity means either it is written by odd number of cycles or even number of cycles, up to the order or parity of the factors. A product of disjoint cycles. Each of which of which has length at least 2. Okay. Proof. Uniqueness, I just proved that it is written by disjoint cycles. For uniqueness you have to uh, go more details, so I will discuss uniqueness if time permits. Rest of them is very easy. Start with 1. Let f let sigma be a permutation. Let sigma belongs to S. Consider 1, sigma 1, sigma square 1, dot dot. If dot dot this side, then there exists k belongs to natural number such that sigma to the power k equals to 1 equals to 1, because you know that Sn is finite order, it is n factorial, so every element should finite order. So if 1 sigma 1 sigma to the power k minus 1 equals to in, then sigma can be written as this cycle 1 sigma 1 sigma to the power k minus 1 1, and we are done. If not, then pick a list element from say I1. Then again consider I1 sigma to the power I1 this set. So there exists k1 belongs to natural number such that choose such list k, okay, such that sigma to the power k1 I1 is I1. Choose such list k1. Then 1 to n if check these two are disjoint, this is a b, check a intersection b is empty, and then we are done. otherwise repeat. This process will take will terminate after finite step, because 1 to n is finite. So we are done. Now example, suppose I write randomly 1 2 3 4 5 6 7 8 9 10 11 12 13 14, just randomly 2 5 6 1 3 4 8 10 9 11 14 13 1 2 3 4 5 6 7 8 9 10 11 12. Just write sigma is here. Now 1 goes to 2, 2 goes to 5, 5 goes to 3, 3 goes to 6, 6 goes to 4, 4 goes to 1, stop. Now what is the least element of step 1? Least element of 114 minus 1 2 3 4 5 6, I write 1 2 3 4 5 6, right? So it is 7. Then start. 7 goes to 8, 8 goes to 10, 10 goes to 11, 11 goes to 14, 14 goes to 12, 12 goes to 13, 13 goes to 7, stop. Note that these two are disjoint, because sigma is bijective. If some element are same, then it will create a problem, because all time you are applying sigma, so injectivity will lose. Okay, so what is this union? 1 2 3 4 5 6 7 8, I think least element is 9, and 9 goes to 9, 10 14 1 2 5 3 6 4 7 8 10, 9 is missing, 11 12 13 14, only 9. So 9 goes to 9. So you can write sigma is I call sigma 1 sigma 2. So disjoint product of cycles sigma 1 sigma 2. Okay, now next observation, one two three, is it 1 2 1 3? Is it true or not? One two three, is it 1 2 1 3? What is 1 2 1 3? I write here. Now if we product, then what happened? Hello. প্রোডাক্টটা করো। I should write 1312. So 1312, 13, what is 1 goes to 2, 2 goes to 2, then done. 1312. It is better. One three 1 2. So 1 goes to 2, 2 goes to 2, 1 goes to 2, 1 goes to 2, product. So 2 goes to 1, 1 goes to 3, 2 goes to 3. Then 3 goes to 3, 3 goes to 1, 3 goes to 1. So this is 1 2 3. Okay. So we can write 1 to n. It has 1 n minus 1, 1 2. I can write it as this one. So, and I1 IR, you can write it as I1 IR minus 1 I2. Product is from here to here. Okay, this direction. In my notation. So every cycle can be written as product of transposition. Moreover, if R is if a transposition of, if a cycle of length n, if a cycle of length r, then it can be written as r and r is odd, then no, I write enter, then it can be written as r plus 1 number of transpositions. Okay, so if r is even, then it is odd. If r is odd, then it is even transposition. Okay, now note that another observation, if sigma belongs to Sn has cycle structure, sigma equals to a1 ar1 b1 br2 dot dot, then for any tau belongs to Sn, tau sigma tau inverse has same cycle structure, and tau sigma tau inverse equals to actually tau a1 tau ar1 tau b1 disjoint cycle structure. Tau br2 dot dot. Okay, so you have to see that tau sigma tau inverse tau ai, what is this? Proof. What is this? Tau sigma ai. Now sigma ai is ai plus 1. If 1 less than I less than r1, okay, if I equals to r1, then sigma a1 is your ar1 is your a1, a1, this is tau sigma tau inverse tau ar1 equals to tau a1. So similarly for B, similarly for B, 1 br2 for this cycle, and so on. If some element are not in union ai, a1 to ar, b1 to br2, that means if some element j, if j belongs to 1 to n fixed by sigma, that means sigma j equals to then what happened? Tau sigma, is it fixed by tau sigma tau inverse? What is tau sigma tau inverse of j? Tau sigma tau inverse of tau j, what is this? Equals to tau sigma j equals to what is this? J, tau j. So tau j is fixed by tau sigma tau j. So proof is done. So for example, so you need not do for disjointness, there is no disjointness, so just product of cycle, it is okay. Okay, now suppose tau is your 4 5 1 6 sorry 5 6 1 6 5 4 3 2 random, and sigma is your 2 4 5 1 3 1 2 3 4 5 6. Then what is tau sigma tau inverse? What is this? Equals to tau 2 tau 4 tau 5 tau 1 tau 3 tau 6. Now what is tau 2? Tau 2 is 6, tau 4 is your 4, tau 5 is your 3, and what is tau 1? 1, tau 3 is your 5, tau 6 is your 2. So this is your calculation. Okay. Now one observation is observation Sn is generated by one two 1 3 1 n. There are three set of generator 1 2 2 3 n minus 1 n, and number 3 1 2 1 2 n, this cycle. So these are generating set of Sn. So very easy proof. We know that every sigma belongs to Sn. Sigma can be written as product of cycles and every cycle can be written as product of transpositions. Therefore any sigma therefore sigma can be written as product of transpositions, written as product of transposition. Okay, let IJ be any transposition. Note that AB square is the identity. AB is transposition. AB is a transposition where AB is a transposition. This implies AB equals to AB inverse. So what is 1I 1J 1I? What is this? This is 1I 1J 1I inverse. That is tau sigma tau inverse, where tau is your 1I. So this is equals to, what is this? From the previous calculation, this applying just tau here equals to tau 1 tau I. Now tau 1 is your J, sorry, what is this? Is J, right? This is J. So this is your J. So tau 1 is your I because it is transposition, and tau j is fixed. If j equals to 1, then it is 1, then same thing. So every ij can be any transposition, can be written as product of elements of the set 1 2, this set 1 2 1 3 1n. Hence every transposition can be written as product of this element. Now therefore sigma can be written as product of these elements. Hence, because you write this product for any transposition, this type expression for ij 1 2 1n is the generator of Sn. Next, now 1j, this is your 1j minus 1, j minus 1 j, 1j minus 1. Same thing, this is 1, this is I write check because this is tau sigma tau inverse. So check that is it true or not. Okay. Now this is generator, and each generator can be written as product of this. Therefore B is also a generator. 1 2 2 3 n minus 1 n is also a generator of Sn, because each sigma can be written as product of this type elements. Now 3, what is that? What is you know that what is 1 to n? To n square. If I write this 1 2 3 dot dot n, 1 goes to 2, 2 goes to 3, that n goes to 1, then what is square? Can you tell me? I write 1 2 n 1 2 sorry 1 goes to 2, 2 goes to 3, and n goes to 1. Then again 1 goes to n 2 3 1. So what is this? 1 goes to 2, 2 goes to 3, 1 goes to 3, 2 goes to 3, 3 goes to 4, so 2 goes to 4 dot dot, then n minus 1 goes to 1, then n goes to 2. So what happened here? So n squared is 1 goes to 3, 2 goes to 4, 1 gap, 4 goes to 6, so n minus 1 goes to 1 and n goes to 2. So this is your thing. So you can check that 1 to n to the power k, what is this? 1 goes to, then what? 1 goes to k plus 1, right? Then 2 goes to k plus 2. So I should write this way. 1 goes to 3. So in cycle notation, what is this? 1 3. So there is a gap of 2. 1 3. 1 goes to 3. Then 3 goes to 5. Right. 1 goes to 3. 3 goes to 5. This type. So I write this way. That is better. So what is that is better, not cycle position. This is better. So I write 1 2 this notation. 1 goes to k plus 1, k plus 2, some 1, then 2 dot dot. What is then n? N goes to, then n goes to what? K, right? This is your. So now take tau equals to that. What is, and sigma equals to 1 2. Sigma equals to 1 2. Then what is tau sigma tau inverse? That is your tau 1 tau 2. What is this tau 1? K plus 1 k plus 2. Okay. So if k equals to 1, then if k equals to 1, then what happened? Then what happened? This imply 2 3 can be written as product of 1 to n. K equals to 2. Then what happened? 3, 4 can be written as product of this. So dot dot n minus 1 n can be written as product of 1 to, what is this? K equals to, I think, what? N minus 2. Okay. 1 to n. So each element 1 to itself belongs to the here. 2, 3, n minus 1 n can be written as product of 1 to n. But this set is a generator. We have proved 1, 2, 2, 3 is n. There is no comma of between transposition. If I put some comma here, it is wrong. Okay. N minus 1 n is the generator set of Sn. This implies this is also so you can check that any 2 cycle and 1 to n, any 2 cycle and 1 to n, or any n, if p n is a prime, then any 2 cycle 1 to n, any p cycle can generate sp. Also a generator a generating set of Sn. Next, what about An, alternating group? Okay, what about An? An is subgroup of Sn. An equals to F belongs to Sn such that F is even. Check that. I should write subset here, then check that it is An is a normal subgroup of Sn, and cardinality An is exactly n factorial by 2. It is index 2, so normality is cardinality n factorial by 2, so index is 2. If it is a subgroup, then it is a normal. It is easy. This is a big lemma. I will use it. let RS be distinct elements of 1 to n, then an 3 is generated by the 3 cycles RSK such that RS is fixed, NE2 fixed, but K is vary. 1 lesser equals to K lesser equals to N, K not equals to RS. Example, take A5 to pick 3 4 belongs to 1 2 3 4 5. Then a generating set for A5 is 3 4 1, 3 4 2, 3 4 5. Okay, this example. Now proof of this lemma. Only you have to use that tau sigma tau inverse is this. This is your formula. Tau, if sigma is a1 dot dot a2, b1 dot dot b a1 dot dot ar1, b1 dot dot br2, and more on c1 dot dot something. I have not written here. Then tau sigma tau is just apply tau. So this is your lemma. Now I have check, all are check. N greater than equals to 3. Okay, if n equals to 3, it is trivial. Assume if n equals to 3, then A3 is your cyclic group and generated by 1 2 3, done. Assume n greater than 3, then every element of an is product of even number of cycles, even number of transpositions. So every element of an is a product of A, B, C, D. There are no common term, or A, B, AC. Okay, product of transpositions, even number, so you can pair them. So product of this type. Now there is no common and there is a common A. Okay, A, B, C, D are distinct. So if we can write this type of elements with help of this RSK, then we are done. Now A B C D can be written as ACB ACD. Check, just product check. And AB AC, it is ACB. Now any 3 cycle RS is your fixed. Any 3 cycle is of the form RSA. If RSA, then it lies in generator. RAS, you have to formulate them. RAB, 1 R from this. SAB, these two are same type, or there is no RS. ABC, ABC not equals to RS, or I does not belongs to RS. Okay, so now RAS, we can write it as RSA whole square. So it is done. You can write it by this RSK type. Okay, RAB, you can write it as RSB RSA whole square. Done. RSK type, K equals to B or A. Similarly, ASAB, what can you write? RSB whole square RSA. And ABC, all check. And ABC, it is RSA whole square RSC RSB RSA. Last one is difficult. Therefore, AN is generated by RSK, that's that 1 lesser equals to K lesser equals to N, and K not equals to RS. RS are fixed. Okay, this is a generator. Next lemma is very important. I just write the statement. If n normal subgroup in AN and n greater or equals to 3 and there is a 3 cycle, in N, then N equals to AN. So after that, use this lemma. Proof of this lemma is very big. So if we assume this, so A6 has no normal subgroup. Why? Not only A6, A5, AN is a group is called simple if it has no normal subgroup. Okay, normal non-trivial normal subgroup. If it has no non-trivial normal subgroup, now an is simple for n greater or equals to 5. This lemma is responsible for this. Now if I ask you some A4 has no group of order 6. You know that A4 proof letter for time being proof letter A4, observe that A4 has no subgroup of order 6 proof. Order of A4 is 12. If there exists H subgroup of A4 such that order of H is 6, order of H is 6, then index so this implies H is normal in A4. Now order of 3 divide order of H. This implies by Cauchy's theorem there exists an element of order 3 in H. Now element of order 3 is a 3 cycle in A4. Three cycle because there if n greater than equals to 6, then there may be possible of product of 3 cycles disjoint, but there is no supply of large n, so it is only 4n. So element of order 3 is a 3 cycle. This implies H equals to A4 by this lemma. Therefore a contradiction because the order of A4 is 12 and H is 6. Now if I ask you that A4 has no subgroup of prime index, A6 has no subgroup of prime index, how to solve it? Take it as homework. Next day I will discuss. আমাকে আজ একটু তাড়াতাড়ি ছাড়তে হবে. If you have any question, please ask me. If you have any question, please ask me. এখানে দুটো জিনিস আমি করাইনি, এই লেমাটার প্রুফ, এই লেমাটার প্রুফটা একটু বড়, আর এই যে এইখানে যে থিওরেমটা আমি লিখেছি, কোথায় গেল দিস, এই থিওরেমটা, এটার একটা রাফ, এটা দিয়েছে নট প্রুফ, ইট ইজ স্কেচ অফ প্রুফ, এটা রাফ আইডিয়া একটা দিয়েছে, এটা নট রিগোরাস, ইউনিকনেস প্রমাণ হয়নি, এটার স্কেচ। কারণ এটাকে রিগোরাস লিখতে গেলে অনেক কিছু লিখতে হবে, তো আমি একটা ফিল দিয়েছি এখানে, তো এটাই এনাফ এখানে জন্য। রিগোরাস লিখতে গেলে আমাকে একটু সাজিয়ে সাজিয়ে লিখতে হবে, টাইমটা লাগবে, সেই জন্য আমি এটাকে অমিট করেছি। ইফ ইউ হ্যাভ এনি কোশ্চেন প্লিজ আস্ক মি। তোমরা চাইলে রিগোরাস একটা প্রুফ লিখতেই পারো। বলো। Okay, no question, then I will stop here.